Hello everyone, welcome back. So today we're going to be talking about chemistry and the molecules of life. So this is might be a difficult chapter because we're going to be talking about chemistry, but we'll try to make it as simple as possible. So if you're ready, let's go ahead and get started. So today we're going to be talking about what is the structure of an atom, what are the subparticles that make up the atom, and where are those subparticles located, and what are the specific charges of those subparticles. So let's go ahead and learn more about the atom. At its most basic level, all life is composed of chemicals. So everything that you consider to be alive is made out of chemicals. So matter is defined as anything that has mass and takes up space. So in reality, everything is composed of matters. Elements are chemically pure substances that cannot be chemically broken down any further. And look at this. Over 90% of the human body is made out of only four elements. That is carbon, nitrogen, oxygen, and hydrogen. And if you combine oxygens and hydrogens, you make up my favorite molecule, water. So water makes up to 75% of your body. Most of your body weight is actually water. So atoms are the smallest unit of element that cannot be chemically broken down into smaller subunits. So atoms are what makes the element. They are arranged in the periodic table by increasing atomic mass. So the nucleus of an atom is the very center of the atom. It is dense because it contains two of the subatomic particles. Atoms are composed of three subatomic particles. First one is the electron. The electron is the smallest of the three subatomic particles. However, it is mighty powerful. In fact, the electron is the reason why elements can make chemical bonds. It is located orbiting around the nucleus and it has a minus charge. The second subatomic particle is the proton. It is found in the nucleus of an atom and it has a positive charge. And the last one is the neutron. It is also located in the nucleus of an atom and it doesn't have a charge. So when you look at an atom or when you look at an element, you're going to see that the protons and the neutrons are located in the nucleus of the atom. And when it comes to the electron, it's basically orbiting around the nucleus. Every single element has the following information. It has an atomic number. An atomic number is equal to the number of protons. And in a neutral element, this number is also going to equal to the number of electrons. So in this particular case, if we're talking about xenon, the atomic number is 54. That means that it has 54 protons. And it also has 54 electrons. Every element has an atomic symbol. In the case of xenon, it's Xe. And every single element is going to have an atomic name. In this case, xenon. And every single element is going to have an atomic mass. An atomic mass is equal to the number of protons plus the number of neutrons. Alright, let's talk more about electrons. So electrons are basically circulating around the nucleus of an atom. So they're moving quite fast. They're always moving. They have a lot of energy. And as I told you earlier, the electrons are the ones that are involved in making bonds. And later we'll talk about what types of bonds do atoms make. Let's talk more about electrons. So shells are the location of the electrons. And as we talked about earlier, the electrons are circulating around the nucleus of an atom. So the valence shell, it's one of the most important because those are the ones that are involved in making bonds. So electrons likes to go in pairs. So whenever they're in pairs, they're happy. They have their partner, if you will. So the valence shell contains up to a maximum of 8 electrons, but most of the time it's not full. So the number of electrons is important for the type of bond that we're going to be making. Again, electrons like to go in pair. They're happy. They don't like to be loners. They want to be with a partner. And so what happens is that if you have an electron that it's by itself, it's going to try to interact with another electron. And therefore, we actually make a bond. So you need 2 electrons in order to make a bond. So let's talk about the periodic table. So each column is called a group. The group that the element is in is the number of electrons in its valence shelf. Each row is called a period. The period that element is in, it's equal to the number of shell orbitals that that element has. Let's talk more about the periodic table. So in the first shell, you can have a maximum of 2 electrons. So when you look at hydrogen here, hydrogen only has 1 electron. When you look at helium, helium has 2 electrons. So that means their shell is full. So that means it's happy. Because remember, electrons actually go in pair. So every single element wants to be on the right where helium is, where neon is, where argon. And the reason for that is because their shells are full. Every single electron has a partner, so they're happy. So these are basically considered neutral elements. They don't like to interact with anything because they're happy. So on the second shelf, so we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. So you can have 1, 2, 3, 4, 5, 6, 7, 8 electrons. On the third shell, again 1, 2, 3, 4, 5, 6, 7, 8 electrons as well. So again, every single element wants to be where helium, where neon, where argon are. In order for them to do this, they're either going to gain electrons, lose electrons, or share electrons. And that's where chemical bond comes into the picture. The first type of bond that you can make is a covalent bond. This is the strongest type of bond that you can make. And the reason why it's the strongest is just think about there's 2 molecules, 2 elements that need just 1 more electron in order to complete their octet. And so what happens is that these elements, they agree on sharing each of those electrons. So there's an equal agreement on sharing that electron, so both elements are happy.